Hello guys, welcome to my YouTube channel, and in this lecture we are going to study about probability and statistics, which is required for data science. Okay, so let's understand some basic concepts here. Okay, so first we'll study about the probability and required things with respect to probability, and then we'll move on to statistics. Okay, so before understanding what is probability, we need to understand what is chance here. Okay, so chance is the possibility of something happening. Okay, so for example, there are three examples here. So first example is, so is it possible that we observe a black color of the sun? So the straight answer is no, it's not possible, right? So the chance of happening is here, it's 0, right? So in example 2, it is said that it is possible that if today is a Monday, then tomorrow is a Tuesday. So definitely it is possible, because there is 100% chance that tomorrow is Tuesday. Okay, because today is Monday, then tomorrow will be obviously Tuesday. Okay, so the possibility chance is 100%. Okay, and the third example is, so is it possible that we have a pizza for dinner? Okay, so in this example it may or may not be possible, because some people may not prefer pizza for dinner and some people may prefer, right? So we may not be able to absolutely sure about having pizza for dinner. So from these above examples, we can conclude that example 1 and example 2 had a clear possibility of occurrence. Okay, so these two examples had a clear possibility of the outcome, but in example 3 we had unclear possibility of occurrence. Okay, so in such a scenario we use probability. Okay, so when a chance takes us to a situation where the outcome cannot be predicted exactly. Okay, so if there is an unclear possibility of occurrence, then probability is used to quantify the variability in the outcome. Okay, so basically if the decision is to be made is unclear, or there might be different outcomes with respect to the decision, we can use the probability. Okay, so what is probability? So by probability we measure the likelihood of an event in which we are interested. Okay, so now we will understand what all things are there in the probability. Okay, so first is, what is likelihood of an event? Okay, so the likelihood of an event is the frequency with which the event may occur. Okay, for example, you can take, if the coin is tossed. Okay, so the probability or the likelihood of an event to be occurring is head, that needs to be calculated. And what is the likelihood of an event where there is tails? Okay, so those are the two events. Okay, so that is likelihood. Okay, so with respect to this diagram, there are some explanation here. So the process of observation of an activity is termed as an experiment. Okay, so here we can consider the experiment of tossing a coin. Okay, so that is that is known as an experiment. Okay, so the results of an observation are as termed as outcome of the experiment. Okay, so here when you toss the coin, okay, so whether it will be a heads or tails, that is known as an outcome. Okay, so the results of an observation are termed as an experiment. Okay, observation are as termed as outcomes of the experiment. Okay, so the events for which we cannot calculate the outcome, those experiments are called random experiments. Okay, so for example, rolling a die, then tossing a coin, drawing a card from the deck, for these examples we cannot calculate the outcome. Okay, so those are known as random experiments. Okay, so rolling a die, so the occurrence of 1 in rolling a die is random. Okay, so those are known as random experiments. Okay, so sample space is nothing but, for example, if you are tossing a single coin, then sample space will be only head or tails. Okay, but if you are tossing two coins, then the sample space will be head head, then head tail, tail head, then tail tail. Okay, so here event B and event A can be different. Okay, for example, in event A you can get only head head and tails tails, and in event B you can get head tails and tails head. Okay, so probability of event A is this much, and probability of event B is this much. Okay, so this is the event and this is the frequency of occurrence. That means how frequent the event occurs with respect to this, the calculation is termed as probability. Okay, Now we will understand sample space. Okay, so sample space is the set of all possible outcomes of the random experiment. Okay, for example, if you are rolling a die, then all the possible outcomes will be 1, 2, 3, 4, 5 and 6. Okay, so there are two types of sample spaces here. One is continuous sample space and one is discrete. So it is straightforward. Okay, so value of stock for a company can be between 15 to 25. So that can be 15.01, then 02, 24.98, etc. So continuous sample space. Okay, discrete is, it will be a whole number. Okay, so number of people attending the meeting can be between 10 to 20. It cannot be 10.1, right? So it will be whole number 10, 11, 12 and 20. Okay, so there are two types of events which can be occurred. So one is dependent event and other one is independent event. So dependent event is occurrence of an event that affects the occurrence of another event. For example, if a series of car manufactured by a company has some defect in it, highly likely that the share values get hit. That means whatever car you are manufacturing, and if there is some defect in the car, then those defects get negative feedbacks, and so does this affects the share price of the cap or the market, you can say. That means if the car value is good, then more and more customers will buy, and obviously the share price will go higher. And if the feedback is negative, then less and less people will buy, and so does the price will be dropped in their share. Okay, so this is known as dependent event. And in independent event, the occurrence of an event doesn't affect the occurrence of another event. For example, so sale of a particular model of a car in Japan and production of nuts, you can say, no need to understand Erica, just the nuts in Sri Lanka, are likely to be independent. That means there is no correlation between manufacturing of a car and nuts, right? So there is no sufficient evidence that they are dependent. That means they are independent events. Okay, so next is set. Okay, so what is a set? So before that, we need to understand metaphrasing here, one term. So it refers to a literal translation. That means it involves word by word and line by line translation without loss of information. So metaphrasing is nothing but you phrase something in such a way that there is no loss of information. Okay, so sets and Venn diagrams facilitate the metaphrasing of the real-time experiment, okay, to a mathematical model. Okay, so for example, sets help in translating the problems into mathematical representations, and Venn diagram helps represent sets graphically. Okay, so you have studied these concepts in your 10th standard, I think. Okay, hope you understand. So basically these are some pretty much simple concepts, just you need to read it and you can understand it. Okay, so what is a set? A set is a collection of distinct objects. Okay, so it is a collection of all possible outcomes. Okay, so distinct means no repetition of things is allowed here. Okay, so the set helps to translate the problems into mathematical representations. Okay, so there are two types of set. One is finite and infinite. Okay, so if a set contains finite number of elements or sample space is finite, okay, or the outcomes are countable, then the set is known as finite. If the outcomes of an probability or an event are infinite, then it is known as infinite set. Okay, so set of all possible positive real numbers is like 0, 0.011, then 1.5, etc. So here it is infinite. Okay, so this is finite, that is rolling of die. Okay, now there are a few terms you need to understand with respect to set. So intersection, so this gives the common elements of set A and B, that is known as A intersection B, and union will give you all the elements of both the sets, that is A and B, but without repetition. Okay, and complement is nothing but you will get a complement of set is represented as A bar. That means that means whatever, if you are comparing two sets, then whatever elements are available in set A, so complement is nothing but it will not involve those elements. Okay, or the opposite, you can say. Okay, so and the differences of set A and B is represented as A minus B. Okay, so these are some representations using Venn diagram. So this is A intersection B. Okay, so it involves common elements from both A and B, and A union B involves everything. So here A bar intersection B is nothing but A bar is you cannot involve this. That means complement is just the opposite. Okay, and then intersection is common, but we are not involving A bar, so just the B. And then A belongs to B. Here B is the population, you can see, and A is a subset. Okay, So that is this, and here this is a sample, overall sample or sample space. Okay, so here this acts as a superset and this acts as its child. Okay, and then a bar is nothing but the elements are not involved, but everything is involved, including the sample space, elements of B and everything. Just we are not including the elements of A here, that is a bar. And A intersection B is this, but we are not involving this, but everything is involved. Okay, bar means the opposite. Okay, so this was all about today, guys. Like we learned about some basic concepts of probability, understanding with probability, and then sample space. Okay, and then we learned about some simple concepts of sets. Okay, that is union, intersection, etc. Okay, so if you learned something from this video, do hit that subscribe button, and until then, take care. Bye bye.